So you guys go ahead and copy these vocabulary words down, independent events and dependent events. Pause the video whenever you need to get caught up. That's the beauty of being able to do this online, right? You can pause me whenever you need to. So, independent events. When one event does not affect the outcome of the other. For example, you toss a coin twice. The first toss does not affect the second toss. So that's what independent events means, right? You get the probability for one, then you ask about the probability for the other, but the first one doesn't really affect the other. So that, that might make sense, it might not, but let's look at the other one. Once we look at the other one, it should make more sense if it doesn't. So what does dependent events mean then? So for dependent events, the outcome affects the outcome of the other one. So for example, let's say I had a bag and there's marbles in there, and I was picking the marbles, right? And I said, what's the probability? Let's see. You pick one marble, right? And then you leave that marble out. You don't put it back in the bag. That's going to affect the probability of the next time you pick another marble, because the total number of marbles will change, and the total number of desired outcomes or the question they're asking you, that whatever they're asking you about is desired outcome, right? That will change also. So that's the difference between independent events and dependent events. Dependent events, the first one affects the second. Independent, the first one doesn't affect the second. All right, so pause the video if you guys need to finish up on that. Otherwise, we're going to move on. So this problem here, I wouldn't expect you to write this whole thing down in your notes. So let's see. We're just going to take a look at this. So let's look at an example of independent events. All right. So I have a number cube and I have a spinner. And we're going to roll the die and we're going to spin the spinner. And the question is, what's the probability of not spinning blue and then rolling a 3 or a 4? So there's some words in there. We got to figure out what those words mean when it comes to probability. So first of all, let's talk about and. And normally means what in a math class? And hopefully you said plus, right? That's what it normally means. However, when you're talking probability, you're talking about the probability of something happening and then the probability of something happening, both of these happening. That actually means times. So this is kind of a new skill here. When you guys see the word and, it means plus, yes, but and for a probability problem actually means to multiply. So that's the first skill. Let's talk about another skill here. What about not spinning blue? Well, if they're asking for the probability of not spinning blue, then we have to pick all the colors that are not blue, and they're asking what's the probability of those. So let's do this problem. So let's do the first one. Do one at a time. What's the probability of not spinning blue? All right, so take a look at your spinner. Did I say spinning? I hope I said that right. All right. Every color that's not blue is 1, 2, 3, 4 colors. Out of that's called desired, right? Desired means what they're asking me to find. Out of the total, the whole thing, there's 5 colors total. So the probability of not spinning blue could look like this: P with parentheses and then not blue in parentheses. This notation here means the probability of not spinning blue would be 4 out of 5. There's every time, if you did this 5 times, 4 out of 5 times, you should not spin blue. That's what that means. Now let's look at the probability of rolling a 3 or a 4, and that's another skill. In math, if you have a probability question and you see the word or, that's the one that actually means to add. Okay? So the probability of rolling a 3 for a number cube, there's 1 3, that's desired, right? 1 3. And there's 1 4. Excuse me, I wrote that incorrectly. Sorry about that. I messed up because I wrote, there is 1 3, but there's 1 3 out of 6 sides, right? You're supposed to put total on the bottom, not the number 3 on the bottom. Do you guys see my mistake? There's 1 3 out of 6 total. So it should be 1 over 6. 1 over 6 chance of rolling a 3. But they say the word or. So it could be 1 out of 3, or it could be a 4 out of 3. A 4, or it could be a 4, right? A 4, how many 4s are there? 1. How many sides are the total? 6. So when they say or in a probability question, you're adding these two because there's a 3, there's a 4. So if I had 1, 3, and 1, 4, we add those two, there's two choices. Out of a 3 and a 4, there's two of them. Or 2/6 chance, which reduces to 1/3. Okay, so let's back that up in case I lost some of you there. Let's just kind of explain this again. Let me try to say it a little clearer this time. Probability of rolling a 3 or a 4. Well, how many are 3 or 4? 1, 3, 1, 4. There's a total of 2 desired this time. How many sides? 6 sides. So a 3 or 4 is 2/6, which is 1/3. Okay, so let's back up. Let's start from the beginning again. What's the probability of not spinning blue? 4/5. What's the probability of rolling a 3 or a 4? Well, since there's two of them, 2/6, which reduces to 1/3. So we have two probabilities, right? We have the first one, not spinning a blue, is 4/5. Second probability, rolling a 3 or a 4, which is 2 out of 6, which reduces to 1/3, right? And the probability of doing both of these things, this is the word and comes into play. Both of these things means we have to multiply the two probabilities. So and in probability doesn't mean plus, and in probability means to multiply. So we can do our factor trees, cross out our ones. In other words, multiply these fractions, make sure it's simplified. So we got a 4 out of 15 chance of that happening. Now 4 out of 15 chance, all fractions are what? Division problem. So 4 over 15 means 4 divided by 15, which gives me a decimal that rounds to about 0.27 or 27 hundredths. And 27 hundredths, move the decimal 2 times, gives you a probability of about 27%. So of course, percent means out of 100, right? So if you did this experiment 100 times, 27 out of those 100 times, or 4 out of 15 times, you'll roll something that's not blue, and you'll roll a 3 or a 4. That's how that works. Okay, so let's look at our skills again. Or means to add, right? Not blue, count up the ones that are not blue. And means to multiply. Okay, those are the new skills we're talking about today. Okay, what's the likelihood of this happening? And that part's review, isn't it? Likelihood means it's impossible, unlikely, as likely as not, likely, or certain. And we know that in the center, it's as likely as not. Anything after 50%, but before 100% is likely, right? 0 is impossible, but anything between 0 and 50 is unlikely, unlikely. And I apologize for writing sloppily. It's tough to write on this pad, okay? Unlikely. So 27% is unlikely. It's unlikely that these two things would happen. All right, let's go ahead and move on to our next problem now. And of course, if anything I say on these lessons doesn't make sense, pause the video, try the problem again. Once you get it right, then you move on. So, next problem. We're going to make sure that we note this down, that in a math class, if we're talking about probability, or means to add those two probabilities together, and means to multiply. So, what about this problem here? If I have a number cube and I toss it, I roll the die, and a coin and I flip it, what does this question mean right here? Well, capital P with parentheses next to it is a probability question. So this is asking us to find the probability of flipping the coin and getting a heads, and what does that mean? That means times, doesn't it? And rolling a 3. So, in order to do that and question, you guys are going to have to find the probability for both. Hopefully you guys remember the probability of flipping a coin and landing on heads is 1/2, right? Desired outcome means heads or tails, excuse me. There's only one tail side, that's tails, and two sides total. So probability is desired over total. And the 3, there's only one 3, right? We don't use a number, actually the number 3. Just ask how many 3s are there. There's one of them. How many sides are there? 6. So when we have that and question, we got to take our two fractions, multiply them, and we have our probability of 1/12. Okay, now we could convert that to a decimal by dividing top divided by bottom. And on a calculator, it looked like this. 1 division 12. We get our number. Without a calculator, it looked like this. In and out. Right, the top goes in, bottom goes out. Decimal. 12 does not go into 10, so we add zeros. And then we add 8, and then we just keep doing that division there. Okay. And then to convert this to a percent, we would move the decimal 1, 2 times. So if we round it to the nearest percent, it's 8.3 repeating percent. If I look at that, if it's 5 or higher, this goes up. 4 or less, it stays the same. So it's about 8% chance of this happening. So let's go ahead and pause the video. Do that again if you didn't get it right. Get it right before you move on. Next problem. Let's find the probability of flipping the coin and getting a heads and then rolling an odd number on the die. Pause the video and try that on your own first. So let's see how you did. Well, the probabilities of a heads, well, there's only one side that has heads out of two sides. So the probability of the coin landing on heads is 1/2. The probability of rolling an odd number, well, there's 3 odd numbers, right? If you're counting, 1 is an odd number, 2 is not. 3 is an odd number, 4 is not. 5 is an odd number, 6 is not. So we got 1, 3, 5. There's 3 odd numbers out of how many sides total on a die or a number cube? That's 6. So 3 out of 6 chance. Yes, you can simplify that to 1/2. And means times. So if I simplified it and I multiplied, I'd already have a simplified answer. But if I don't simplify right away, then I'm still going to, when we multiply fractions, right, we prime factorize, cross out our ones, and we get 1/4 either way. But what we don't want to do, right, for later, for 8th grade, for specific for algebra, I don't want to multiply my numerators and denominators and then try to reduce later, because these numbers are going to get bigger later, or they're going to be polynomials, right? We don't want to be in the habit of multiplying first. We want to be in the habit of prime factorizing, crossing out our ones first. That's what's going to get us through algebra. So let's practice that now. So the answer was about 25%, because 1/4 is 25%. Again, of course, you guys, if you didn't know that, you'd go 1 divided by 4, which is 0.25, converted to a percent, move the decimal 2 times. All right, do that one again until you get it right. Once you're ready to move on, you guys go ahead and pause the video and try this problem. So, what's the probability of rolling a heads? We know that's 1/2. Probability of rolling a 7. There's 0 7s out of 6. Now, 0 over 6 is 0, right? And 0 times anything is just 0. Well, that's impossible. There's a 0% chance of that happening. What's the likelihood? Impossible. All right, hopefully you guys understood that problem. You guys go ahead and pause the video and try this next problem. So it says we have a committee of 5 girls and 4 boys. Question: what's the total number of students? Of course, that's 9, right? Because we need to know total for probability questions, don't we? So it says, what's the probability both will be girls? So you're going to pick a girl, right? And then I want you to imagine the girl's already been picked. So when you find the probability the second time of picking a girl again, will you consider that girl again? No, you won't, will you? Will the number of students be the same after you've already picked out girls? She's not considered anymore. And the answer, of course, is no. So what would you guys call this? Independent or dependent events? So this is an example of dependent events, right? That last one that we did, those are independent. The coin doesn't affect the the die. And over here, it is dependent because the number of students. Once you pick a girl, you're not gonna pick her again, right? She can't fill two spots at one time. So this is dependent events because after you pick a girl, it's gonna change the numbers. So let's take a look at the probabilities, right? This is another one of those, I want to pick a girl and then another girl. So if that's going to happen, this is an and question, which means we're going to be doing some multiplying, aren't we? But first we have to find the probability of picking a girl. So for the first event, what's the probability of picking a girl? Okay, so the desired outcome is to pick a girl for that position and 9 total. So the probability is 5 out of 9. If you did it 9 times, you'd pick a girl 5 times out of 9, theoretically, okay? However, for the second event, one girl's already been picked. So now there's only 4 girls. One student has been picked. Now there's only 8 total. So the probability of picking a girl again is 1/2. See how the dependent event affected the numbers? 5 went to 4 and 9 went to 8 because one girl's already been picked. She's no longer one of those students that are being picked. That's supposed to be students being picked. I don't know why I drew that. All right. So, but what's the probability of this 5/9 have to do with this 1/2? Well, if they're both going to happen, or the word and, if they're both going to happen, what does that mean? That word right there means we have to multiply our probabilities. So I take 5/9 times 1/2. Of course, we do factor trees, cross out our ones when we're multiplying, right? And then I get 5/18. And in order to convert that, of course, we divide top by bottom. We get about 28% chance of that happening. So you guys go ahead and pause the video and make sure you do that again. If you didn't get 28% this time, do it again until you get it right. If you've already done that, let's move on to the next problem. I want you guys to pause the video right now and try this on your own first. So it says, from a committee of 3 girls, 4 boys, same question, isn't it? 2 are randomly chosen. What's the probability they're both going to be boys this time? Well, let's try that. The probability of picking a boy, well, if we're asking about boys, that's considered the desired outcome, right? So the desired outcome is to choose a boy this time. Then there are 4 boys. It's desired over total. There's 7 total students. So the probability of picking a boy the first time is 4 out of 7. Now, the probability of picking a boy the second time, well, we've already picked one boy, right? So now there's only 3 boys. So there's 3 boys. Now there's only 6 because I'm not going to pick that one boy again, right? 3 out of 6. So if I want both of these things to happen, that's an and question. And an and question means to multiply the probabilities. So 4 is 2 times 2. I'm going to prime factorize before I multiply fractions. 6 is 2 times 3. And I cross out my ones. 3 over 3 is 1. 2 over 2 is 1. My reduced answer will be 2/7. Take your calculator. 2/7 is 2 divided by 7. Or about 0.29 or 29 hundredths, which is about 29%. If you've already done it correctly, let's move on to the next one. Otherwise, you know what to do. Pause the video, do it again to do it right on your own. Pause the video now and try this problem. Looks like the exact same problem as the last one, doesn't it? Well, actually it isn't. Because on the last problem, we got 7 when we added these two, didn't we? And I did that on purpose to try to trick you, didn't I? Did you let me trick you? I hope you didn't. Our total isn't 7 anymore, is it? It's going to be 3 plus 7 or 10. So let's see how you did. So the probability of both being girls, well, there's 3 girls, 10 total. So hopefully you know 3 out of 10 is 30%. If you don't, that's fine. But we've already picked one girl, so now there's only 2 girls. So the probability of picking a girl again is going to be 2 out of 9. Because now there's only 2 girls, And 2 plus 7, now there's only 9 total students because one girl's already been picked. So I want to do both these things. Both these things mean and. And in probability doesn't mean plus like it does every other problem. It means times. So I'm going to go ahead and prime factorize. 3/10 is 3 over 5, 2 times 5. I'm prime factorizing, right? That means factor trees. 2 on top, that's prime already. 2 is our smallest prime number. 1 isn't, right? 1 is not considered prime. And 9 is 3 times 3. And then I cross out my 1s. There's a 2 on top and a 2 on bottom, right? Now, if there's nothing left, remember I crossed out 1s. 2 over 2 is 1. These are both 1s technically. So there's still a 1 on top. There's nothing there. There's a 1. It's not a 0. 5 times 3 on the bottom is 15. So I have a 1/15 chance of both of these things happening. And 1 over 15 is going to be about 7%. Just in case you aren't sure how to get that, you go 1 divided by 15 because it's in and out, right? And as you can see, we got 0.06 and then 6 repeats. Move the decimal 2 times, rounds to about 7%. How'd you do on that? Okay. Now, we have one challenge problem here. I want you guys to pause the video. I want you to give a sincere, at least 5-minute effort on this. Try to get this problem, both parts, on your own before you watch the video. Pause the video now and try it. All right. So the question they're asking us is, the first part right here is, what is the probability that both packages are defective? And it says up here, a company has determined 2% are defective. So if we're going to do this 2 times, we want something to happen, and then we want it to happen again. This is another and question, isn't it? So 2%, now definition of percent means what? It means out of 100, right? So 2% as a number is 2 over 100, which of course reduces to 150, 1 over 50, 1/50th. Or yes, 2% is also 0.02. This is 3 ways, 1, 2, 3, 4 ways of writing the same thing, isn't it? All right, so percent isn't necessarily a number. It's a number out of 100. Okay, so we have a probability of 1 over 50 or 0.02. Now, the probability of that happening 2 times means this times itself. So we got a couple options here. We can either take our calculator and go 0.02 times 0.02, and the probability of that happening as a decimal is 4. You guys remember how this goes? First it goes tenths, right? Then hundredths, then thousandths, then 10,000ths. So the way you read this number, try to say it out loud right now before I tell you how to read it. It's 4 10,000ths, right? That means 4 as a fraction is 4 over 10,000. So that's what it is as a decimal. What would that be as a percent? And if you move the decimal 2 times, you would get about 4/100ths of a percent. So not even 1%, right? If you took a percent and you chopped it up into 100 little pieces, you'd have 4 of those tiny little pieces. That's what that means, okay? So don't confuse these two. I wouldn't put a percent right here. That's the decimal number. This is the percent. These two are the same thing, but this, watch, if I put a percent here, would not be the same thing. That would be incorrect. And problem is, a lot of you would call this, some of you, not a lot of you, some of you would think it's actually 4%, which is way bigger than this number down here. So know this, you only move the decimal 2 times. All right, converting decimal, 2%. You only move the decimal how many times? 2 times, that's right. So that's how we do this first part. How'd you guys do in that first part? Let's take a look at B now. So we know the chance of this happening is well, let me say this different. The probability that 2 packs are going to be defective is 4/100th of a percent, or 4/10,000ths, right? Now, if some of you did this differently, I should do it another way actually, because some of you might have done it differently. Some of you might have taken the 2 fractions, 2% meaning 2 over 100, And you might have gone like this. You might have gone 2 over 100 times 2 over 100. Sorry about my writing. And if you didn't reduce your fractions, you would have got 4/10,000ths that way, which is the exact same number as this, 4/10,000ths, okay? Some of you might have reduced your fractions. 2 hundredths is 1/50th times 1/50th is 1 over 25 hundredths, right? Remember multiplying by multiples of 10, just multiply the numerators and then count up your zeros and add them. Not numerators, sorry. Multiply that first numbers and then count your zeros. Or 1 2,500ths. Let's check what 1 2,500ths is. That's 1 divided by 2,500. It's still the same number no matter how we do it. So let's go to the second part of this question. Second part of this question says, if you produce, what's that number there? It looks like we have, this is hundreds, right? And then after hundreds, we have thousands. And then after thousands, we have millions. So it looks like 1 million. The company produces 1 million packages. Predict a number in which both cups will be defective. Well, if that's going to happen 0.04% of the time, and I want to figure out how many out of a million that is, well, then I'm just basically finding 0.04% of 1 million. Okay, and of course we learned in class we can use percent proportion. If it's a percent, you can use percent proportion. Percent over 100 equals is, what is 0.04% of 1 million, is over of equals percent over 100. And then we can cross multiply and divide. That'll work. Grab your calculator and work that out if you want to do it this way. But some of you know that of means times in math, so we just multiply. But be careful. When you multiply, you must convert your percent to decimal. So in other words, use your decimal here. If you're going to just do the shortcut, you're going to type in a million. A million has 6 zeros. 1, 2, 3, 4, 5, 6. And then times 0.4 thousandths, 10 thousandths. You have to use a decimal equivalent. So 400 out of a million will have both cups be defective according to this probability up here. All right. Now you guys make sure you know these problems well before you take that quiz next week. Don't try to learn it while you're taking the quiz. You'll run out of time and that won't be good. So I want you guys learning this stuff. All right. We will see you guys soon. I hope you guys are doing well. Take care.